Okay, so these are the try these on the back of the notes that we did in class today. I'm just going to work through it real quick. Again, you don't have to do these try these, but this is just if you wanted to try them and you wanted to see how they're done and extra examples. I'm just going to run through these. Again, your homework assignment for tonight is actually over here. So it's from the Springboard book. It's page 311, 314, and 316. So again, make sure that's what you're doing for the homework assignment. This is not the homework assignment what I'm getting ready to do. These are just extra practice problems that if you want to attempt them, you can. All right, so now for the try these, the first one here, we have our triangle labeled. And if you notice, this is a Pythagorean triple, the way it's labeled. You will see questions where maybe you won't be given all the parts. And a lot of times, if you're not given all the parts, you might have to find a missing side using either Pythagorean theorem or a Pythagorean triple. For this one, you have all the parts, so we're going to find sine, cosine, and tangent of each one of these angles. So for sine of A, we have, using A up here, sine is opposite over hypotenuse, so opposite of A is 12. Hypotenuse is 13. Then on cosine of A, cosine is adjacent over hypotenuse, so adjacent is 5. Hypotenuse is 13. Tangent of A, opposite over adjacent, so 12 over 5. Now, for these, again, since we already know these, we don't have to go and look at our triangle again, because sine of A should be the same as cosine of B, so this should be the same as sine of A, 12 over 13. Sine of B should be the same as cosine of A, so this should be 5 over 13. And tangent of B should be the reciprocal of tangent of A, so this should be 5 over 12. Now, if you want to double check on your triangle, here's B, opposite over hypotenuse, 5 over 13. For cosine, adjacent over hypotenuse, 12 over 13. For tangent, opposite over adjacent, 5 over 12. So again, you can do it either way, but once you have one set, you shouldn't have to do the others, because the cosine of one of these values will be equal to the sine of the other. The sine of one of those values will be equal to the cosine of the other. That will always hold true. And then the tangents always have to be reciprocals. On this next part, you just had to plug these into the calculator. So I'm just going to use this calculator and plug these in. So we have sine of 64. Again, double check, make sure your calculator is in degree mode. If it's not in degree mode, you're going to get these answers wrong. Cosine of 81. So 0.156. Tangent of 44. We have 0.966 after we round it. Sine of 37. It's going to be 0.602. Cosine of 22. It's going to be 0.927. And tangent of 52 is going to be 1.279. Ooh, actually, there's another 9 after that, so that's going to round that up, which rounds the next one up. So this is going to be 1.28 after rounded. Even though we're rounding to the third decimal would be 0, and that would end up being 8. All right. Again, one other thing to mention here, I said this in class, but sine and cosine will always be numbers less than 1. Because when we're talking about right triangles, the hypotenuse is always the longest side. And with sine and cosine, the hypotenuse is the number that's on the bottom of our ratio. Therefore, the bottom number is always bigger on the fraction. It should always give us a number less than 1. All right, look at the next set. On the next set, again, first 3 here are written as equations. We're solving for the missing angle. These bottom 3 are written as expressions. You're doing the same thing. In order to find a missing angle, you have to take the inverse sine, inverse cosine, inverse tangent, because we have to get rid of sine, cosine, tangent. Here, they already have the inverse of the ratios written, so we just have to do the inverse and then write what the angle measure is in degrees. We're going to round these to the nearest whole number. So, for the first one, we're going to be doing the inverse sine to get rid of sine. So if I wanted to actually show work on this one, since this is actually an equation, I take the inverse sine of that and the inverse sine of this. These cancel out, leaving me with just theta, and have second inverse sine of 0.4384, which gives us 26 degrees. So now this one, same idea. We're going to do the inverse cosine to get rid of this. So inverse cosine of 0.669. So that's going to give us 48 degrees. Inverse tangent on this one, so 2.904. That's going to give us 71 degrees. On the next one, again, these are already written with the inverse. It's the same thing. So inverse sine of 0.891. It's going to give us 63 degrees. The degree symbol is already written. It's kind of low though. I'm just going to rewrite it because I don't like it down there. All right, on the next one, cosine. So inverse cosine of 0.242. That's 76 degrees. And then inverse tangent of 6.314. That's going to be 81 degrees. All right, on the next one. So now this next section, we actually have triangles, and we have to find the missing parts of the triangles. So the first two are sides, the last one's an angle. Now, number 4A, we have this angle measure. We have the side that's next to it. So this is compared to this one, this is adjacent, whereas this is our hypotenuse. So adjacent and hypotenuse, that's going to be cosine. Right? So again, if you need to, you can write out your SOHCAHTOA here at the top in order to help you out with this. But SOHCAHTOA is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So now, again, adjacent and hypotenuse, there it is, A and H. So this is cosine. So cosine of the angle measure, 48 degrees, is equal to adjacent over hypotenuse, x over 48. Now, on this one, in order to get rid of the 48, because we want x by itself, we would take that 48 that we're dividing by and multiply it to the other side. Oh, actually, timeout. I wrote that wrong. That's not supposed to be 48. That's supposed to be 18. The hypotenuse was 18. Copied the angle measure again. So, sorry, this was 18. So, sorry, multiplying the 18 to the other side. So we have 18 times cosine of 48 equals x. So, if I clear this out, we're going to type this one in now. We have 18 times cosine of 48. And that's going to give us 12.044. On the next one, we have 72 as our angle that we're using. So compared to that 72, we have this side is our opposite. This side is our hypotenuse. So we have opposite and hypotenuse. That's going to be sine, right? Opposite, hypotenuse, that's sine. So sine of 72 degrees equals the opposite leg over the hypotenuse. Now this one's slightly different because we have the x value on the bottom. Again, we still have to do the same first step, because in order to solve any problem, if your variable's on the bottom, you have to get it out of the denominator first. So we are going to multiply both sides by x to get it out of the denominator. So we have x times sine of 72 equals 9. Now, we're not to our last step because this is not giving us an answer. X is not by itself. We have to get rid of sine of 72. The operation here is multiplication, so we're going to divide off sine of 72. So we're going to end up with just x on this side, and then on the other side it's going to be 9 over sine of 72 degrees. Again, we can type that whole thing into the calculator. So we have 9 divided by sine 72, and x is approximately 9.463. So that'd be our answer. And yeah, they did have answer blanks for us to write it in. So if you want to write it there, you can. That's 9.463. So now, on the last one, this one's different because it's solving for an angle measure. Again, we still set it up the same way. We're going to take the angle that's represented with the x this time, and we're going to label these two. This would be our opposite. This is going to be our adjacent. We're not using the hypotenuse at all this time. So opposite and adjacent. If I go back up here to where I wrote SOHCAHTOA out, SOHCAHTOA, opposite and adjacent is with tangent, the t. So tangent of our angle measure, which in this case is x, is equal to the opposite, so 7 over 12. Now, you don't have to divide 7 over 12. You could leave it as 7 over 12. If you want to divide it, fine. It's going to give you a decimal. It doesn't matter. I like to leave it as a fraction. And then the only thing we have to do here is get rid of tangent. So we have to do the opposite operation of tangent, which is the inverse tangent. So we're going to get rid of tangent by doing the inverse tangent. So x as a degree is going to equal the inverse tangent of 7 over 12. So then, plug that into the calculator. Second inverse tangent of 7 divided by 12. And that gives us x of 30. Now, this one isn't round off very nice to a whole number, but I did say usually when we do these, we're going to round our answers for degrees off to whole numbers. So anytime we're solving for an angle, unless otherwise stated, I'm just going to have you round off to a whole number. So this one, I'm going to round off to 30 degrees. Again, that's approximation, so I should use my approximation symbol, but 30 degrees. And that's it. So those are the try these. Again, if you want to do them, feel free to do so. Those are all the answers. Again, your homework tonight, right here. So make sure you get those problems done, and that's it.